My dear students, hoping that you are all fine and enjoying your vacations almost ending. Now, dear, right now we are solving one more paper two, structured question paper two. So, but again, fresh year, man, 2025 October November series, paper two and variant three. May June already we have discussed. Okay, now this paper, as usual, 60 marks and 1 hour 15 minutes means 75 minutes are there. Some of the data as usual and formulas. And also I have shared with you the formula sheet yesterday if you have gone through this. And don't worry that there are 25 pages of definitions, only 6 pages and formulas are 25 pages. No need to worry about that. Actually, that formula sheet is having a lot of explanations like all the alphabets, I mean the variable which are used into the equation. They are also mentioned before each and every formula. Now, first of all, now define acceleration. So very simple acceleration definition, and that is rate of change of velocity. For 1 mark, straightforward, we'll be writing rate of change of velocity. And let's start. So this is what rate of change of velocity. Then, my dear friends, a rocket is launched vertically from the surface of the Earth. Figure 1.1 shows the variation of the velocity of the rocket with time for the first 20 seconds. So time is there after its launch. Determine the acceleration of the rocket. Again, very simple, straightforward question. How I'm saying straightforward question? See, this is velocity time graph, and we know either you can say gradient of the velocity time graph is acceleration, or a is equal to v minus u over t. So same way, v minus u over t. Now, what is t? T is this 20 seconds. And what is u? That is equal to 0. And what is v? See, this is 2000, 3000, and this is what? Here, this is 3200. Not 3200, 320. So that is what? That is v. So here, this is v. This is 320. So all the data is with us. Simply 320 minus 0 over t. What is the time given? 20 seconds. So 16 twos are 32. Simply answer is 16 meters per second square. Straightforward. There is no trick, nothing. Show that the height of the rocket, height means the distance, above the surface of the Earth at 20 seconds after the launch is 3.2 kilometers. So we know very simple, height means distance, and for a velocity time graph, the area under the graph is equal to displacement. So here they ask for distance, so distance. Displacement is a distance in a particular direction. So simply the area under the graph, my dear friends, that will give us the distance, and that is the area of a triangle. So simply the distance will be equal to 1 over 2 times base times height. So in this case, that is equal to 1 over 2 times base, which is time 20, and height is 320, if I'm not wrong. So see, as we simplify, 2 tens are 20, and then it means it will become 3200, but it is in meters, and they want to be, it should be in kilometers. So divide this one by 1000. So 3200 divided by 1000, it will be converted to kilometers. So what is the answer? Answer is, dear friends, 3.2 kilometer. This is also very simple, straightforward question. There are 1 or 2 questions as usual in every paper, and rest of the things are to the point. Now, the mass of the rocket in B is this. So mass of the rocket is given. Assume that this mass remains constant. So mass is staying constant for this rocket from the launch to its height after a time of 20 seconds. To its height at a time of 20 seconds after the launch. Calculate the gain in gravitational potential energy. So again, very straightforward. See, change in potential energy, gain or loss, that is basically change. So change in potential energy, dear friends, that will be equal to mass is constant, value of G is constant, times delta H. So it is launched from the ground. So initial height is 0 and then maximum height is 3200 meters. So mass is given, that is 2.9 times 10 raised to power 6. Then G as usual 9.81 and change in height is 3200 meters as the answer is in joules, which is system international unit. So my dear friends, we are not going to use 3.2 kilometers. We are going to use simply 3200 meters. So as we simplify this, we are getting the answer. Dear friends, I'm just writing the answer directly. So 9.1 times 10 raised to the power of 10 joules. Okay. Calculate the gain in kinetic energy now. See, they're simple, straightforward formulas. Now, what is there? Calculate the gain in the kinetic energy. Now, gain in kinetic energy is the speed given. Let's see. Yes, speed is there. At 20 seconds, what is the speed? That is 320 meters per second. So the same speed we will be using into the equation. So dear friends, here gain in kinetic energy that will be equal to EK. Gain again, it means change. So 1 over 2 m, even you can write delta v square because change in speed is initial speed was 0, final is 320. So simply placing the values, we can get the answer. Now 1 over 2 times mass, which is, this is the mass, 2.9 times 10 raised to the power of 6 times 320 meters per second is the final speed. And as we simplify, we are getting answer 1.5 times 10 raised to the power of 11 joules. My dear friends, up to here, if you have any question, please feel free. You can ask me. Very simple, straightforward, but looking at this graph, that is important. Now, see, numerically in front of you, nowhere the speed is given. But I have used 320 because come here in part C, he is saying for this rocket from the launch to its height at a time of 20 seconds. Gain in gravitational potential energy, mg delta H, and gain in kinetic energy, that is delta K. Now, at what? At 20 seconds. And at 20 seconds, what is the speed of the rocket? That is 320 meters per second. Now, the next question, 2 marks. Determine the average power output. Again, my dear sons here, very important, dear students. Again, my dear students, very important. See, in the last lesson, also, I couldn't, the recording, I did not share it yet because that was not perfectly good because the net was very slow. I was in a hotel in Medina Munawwara at that moment. So the strength of the signals were not that much good. So there are a lot of fluctuations. So I will re-record it and inshallah, I will be sharing it to you within next 2 days. Inshallah, maybe today evening or tomorrow, I will be sharing that one. Okay, so now here average power output. Dear sons, law of conservation of energy is there. Why? Assume the resistive forces are negligible. Resistive forces are negligible. Okay, if the resistive forces are negligible, then it means law of conservation of energy is there, and energy before conversion, total energy before conversion, which means the input energy is equal to total energy after the conversion, mean to different forms. That is output energy. So total input energy is equal to total output energy. Here we are not going to calculate the useful output power. This is simply average output power. Now, what are the input energies? Of course, this rocket, let's suppose that it is made up of a solid fuel. So, I mean, it is powered by solid fuel, sorry. So that will be having chemical energy. Now, You can observe here that chemical energy is converted into potential energy. There is a gain in potential energy. Potential energy is increasing. Then also there is a gain in kinetic energy. Kinetic energy is also increasing. In general, what happens when somebody falls down or it is launched upward? So gain in one energy is equal to loss in the other energy. Here both are gaining. Why so? Actually, the chemical energy which was there into the fuel tank, fuel chambers of the rocket, that is being converted into kinetic as well as potential energy. So the total output power first. We need average power output. So time is given, that's not a problem. But first of all, we need to calculate the total output energy. And total output energy will be equal to the sum of the kinetic energy and potential energy, mean gain in kinetic energy and potential energy. So my dear friends, first of all, I'm going to calculate average power, no, not power, sorry, average energy output. That will be equal to gain in potential energy plus gain in kinetic. So this is average output power. And what is the power? Oh, sorry, output energy. What will be the average power output? That will be, my dear friends, average energy out over time. So that means equal to delta EP plus delta EK over T. And here I did a blunder. Both P I have written. No, it should be EK. Now the values are with us. Time is with us. We will place the values and we will get the answer. So what is average uh, potential energy? That is, my dear friends, 9.1 times 10 raised to the power of 10. What is average kinetic energy? That is 1.5 times, sorry, gain in potential, kinetic and potential. Gain in potential energy, 9.1 times 10 raised to power 11, and 10, sorry. And kinetic energy gain is 1.5 times 10 raised to power 11. And how much is the time? That is 20. And as we simplify, dear sons, it is 1.2 times 10 raised to power 10. What? No, here in 2025, thanks to Almighty Allah that we have touched these papers in journal, they are asking the efficiency or useful output power. In May, June 2025, paper 2, variant 3, we discussed there was uh, average output power to be calculated. No useful output power. Same is the case here in October, November 2025. So be very careful, read the question carefully that either the examiner is asking useful power, then we need to subtract the wasted one, work done against the resistive forces. Then when he will ask for useful, then there will be, of course, some work done against the resistive forces like in 2025, but they didn't ask they're even useful. So we have to add up the all energies which are shown into the question and which we have calculated already. Okay, so I'm sure this will be very clear to you all and there will be no doubt. Let's move forward to the next question. Define pressure. So definition of pressure, my dear friends, not very difficult. It should be for you. So pressure is, we can say, normal force per unit. Normal force per unit area of cross section. Yeah, cross section area. Area of cross section. Explain how hydrostatic pressure results in an upthrust force acting on a solid object immersed in a liquid. So how the upthrust is acting there. No idea. Uh, let's suppose this is an object that is inside the water. Here inside what? Water, and this is a solid object. Okay, this one is the object. Now we know what is pressure. We know what is pressure. See, pressure in fluids that is equal to pressure in fluids, dear friends, that is equal to rho GH. Now, density of the fluid is constant, liquid is constant, what wherever the object is. And G, acceleration due to gravity constant. Only the thing which is changing, that is the height. Now see, the height over here, just a minute, dear friends. Okay. So now, the height over here, let it be, this is H1 from the surface of the water. And dear friends, from the bottom of this object, this height is what? H2. Now pressure is directly proportional to depth. So it means if I'm naming this pressure, if I'm saying this pressure, my dear friend, this force, one force is up, that force, let's call it this force at the top surface. Let's call that force F1, which is downward. And then there will be a force in the upward direction that will be, let us call that force as what? Let's call this force as F2. Then, my dear friends, and F2 is upward, F1 is downward. So, due to one reason, dear friends, due to one reason, now see, as this depth is more, now see, let me write that H2 is greater than H1 and pressure is direct proportional to depth. So it means P2 is greater than P1. So also, if the pressure P2 is more, so it means F2 force is greater than F1. And this difference in force, like F2 is greater, F1, which is downward, is smaller. So there will be a resultant force acting on this object upward, that is F, and this upward force is the upthrust. This upward force is what? The upthrust. So, my dear friends, again, let me share that this is the solid object which is inside the water or any liquid. So it's two surfaces, top and bottom. They are at different depths, and pressure in fluids is directly proportional to depth. It means the pressure at the top surface, that is smaller as compared to the pressure at the bottom surface. So this difference in pressure will cause a difference in force acting on this object. Why force? Because force will be equal to pressure times area. So area of the surface of an area from the surface and area from the bottom, that is equal, that is same. So it means where pressure is more, force will be more. So pressure is greater at the bottom edge as compared to at the top edge due to the fluid. So this difference in pressure will lead toward the difference in force, and that difference in force will lead towards what? That will lead towards the upthrust. So now I will be writing this one all. So now, my dear friends, I will be writing in my own words, difference in pressure. If you have any question, you can ask me. Difference in pressure at top and bottom of object. of object causes an unbalanced force. Causes an unbalanced force. Force at bottom which is acting upward is greater than force at top. That force is downward as I have drawn the arrows also. This difference in force, this difference in force is equal to upthrust. That's what, my dear sons, we can write. And to understand this, this diagram and this explanation will be handy for you people. Now, a small steel ball of radius R and mass m falls vertically at terminal speed. Now, this is important. Terminal speed V through the oil. The viscous drag force, mean drag force, opposing force, which is always in the opposite direction to the motion of the body on the ball, is given by D is equal to 6 pi eta RV. That is equal to 6 pi eta RV. Okay, eta is the viscosity of the oil. On figure 2.1, that is down, of course, draw the labeled arrows from the ball to show the directions of the three forces that act on the ball. So, first of all, my dear sons, 3 marks are there. See, this 3 marks, and you can do it in 10 seconds. W weight is always downward. Then we also know that upthrust, that is always upward. Upthrust is always upward. And then drag force. Drag force is always in a direction opposite to the flow of the body, opposite to the direction of motion of the body. Now, body is falling down through the water. This ball is falling down through the water or liquid, sorry, oil. So, upthrust will be, sorry, drag force will be in the upward direction. So, you can write here drag force. But do one thing more, my dear friends. Do this diagram with scale better. Why there are 3 marks? And there is a reason when I'm saying in terms of the as the body is in is falling with terminal velocity. So the length of the two arrows, sum of the length of these two arrows should be equal to the length of this one arrow, which is the weight. To show that upward force is equal to downward force, so resultant forces will be balanced and the body will be falling down with constant velocity, that is known as terminal velocity. So weight is always downward. Upthrust acting on a body in a fluid is always upward. Drag force, it is something whose direction keep on switching according to the situation of the question. In this case, the ball is falling down through the oil. So if the ball is falling downward, drag force will be upwards. And from where I brought drag force, it is mentioned here by the examiner, drag force D. Okay, so this was for 3 marks. Determine the SI base units of viscosity. So that is very simple. They gave the equation. Which equation? D is equal to 6 pi eta RV. So I'm writing the same equation. D is equal to 6 pi eta RV. Now, dear friends, as we know, 6 pi is a number. It has 6 pi is a number, so no units with this. So making eta as the subject of equation, it will become drag force over RV. So Drag force. This F is equal to MA over RV. Now we can write the all units. Dear friends, it means kilogram, meters per second square over meter, and velocity again meters per second. So on simplification, meter cancelled with meter, this s raised to power minus 2 with s raised to power minus 1. So what is left behind? Kilogram per meter, and here will be minus 1 actually, per second. You know, s raised to power minus 1 will be cancelled with minus 2 and still minus 1 will be left there. So that's simple, 2 marks, not a big deal. Now the next question. This was very simple. Now next question is, the oil in B has a density of this. So that is the density of the oil, and a viscosity of this. So that is eta in SI units. Okay, so kilogram SI units is eta is kilogram per meter per second. You know, eta viscosity. The steel ball has a mass of this. Mass is also given, and a radius of this. Radius is given. Show that the upthrust on the ball is this. That's very simple. You know, upthrust when the density is there, mass is there. So that is equal to rho, density of the, in this case, oil, times volume of the object, which is ball. Volume of the ball mean object times G. Now, ball is a sphere. What is the volume of the sphere? Volume of the sphere, my dear friends, is 4 by 3 pi r cube times G. All the values are with us. Just let's place the values. So density of the object 920 times 4 over 3 pi r. R is 4.2 times 10 raised to power minus 3. But don't forget to put the cube times G. I'm just writing G, means 9.8. So as you will simplify, of course, answer will be 2.8 times 10 raised to power minus 3 Newton, only 1 mark. Now, what is next? Next is, now determine the uh, terminal speed of the ball. So very simple, again, see, D is equal to 6 pi eta RV. So V is the terminal velocity. Making V as the subject of equation, it will become D over uh, 6 pi eta R. Okay. Now, my dear friends, drag force. We need to calculate drag force. That was up thrust, okay? Now, drag force, for that purpose, this diagram will help us. Weight is equal to up thrust plus drag force. So here, see, weight is equal to up thrust plus drag force. It means drag force will be equal to weight minus up thrust. So that's what I will be using here. So weight is equal to up thrust plus drag force, making drag force as the subject of equation. It will be weight minus up thrust. Now, what is the weight? Weight is mg. Where is the mass? Mass is given here. That is 2.4 times 10 raised to power minus 3. So, dear friends, 2.4 times 10 raised to the power of minus 3 times g, which is 9.81, minus up thrust. We just calculated 2.8 times 10 raised to the power of minus 3. As I'm simplifying it, dear friends, I'm getting the value of d equal to 20. 0.7, roughly I'm writing, times 10 raised to the power of minus 3, that is Newton. Now we can use the equation for calculation terminal speed. So V will be equal to D, which is 20.7 times 10 raised to power minus 3 over 6 pi as it is. Eta we have calculated. Eta not calculated, it is given 4.7. See here, this is eta 4.7 times R. So radius is given 4.2 times 10 raised to power minus 3. So 4.2 times 10 raised to power minus 3. So as we will simplify, my dear friends, answer will be almost 0.0557, almost roughly. So we can write 0.056 meters per second. And it was 3 marks because there were 3 steps. First of all, making the equation, then finding D, and then placing the values and getting the value of terminal velocity. If any one of you is having any question here, please feel free and you can ask me. Now, next, my dear friends, a wire has a length L, cross-sectional area A. The wire is made from a metal that has a Young modulus E and resistivity rho. So define Young modulus of the material. So Young modulus E is equal to stress over strain, or it is the ratio of stress to strain. Only 1 mark. Then state an expression in terms of sum or all of L, A, E, and rho for the resistance Rho of the wire. Now you know we have studied this. R is equal to rho L over A. Instead of R, they are saying R naught. So here we can write R naught. So simply R naught is equal to rho L over A. Straightforward. Nothing special. And if you are not remembering right now this thing, you know resistance is directly proportional to length. So in this case, we can write, no need to show it because only 1 mark. Resistance is directly proportional to what? Length. Resistance is inversely proportional to area of cross section. If we combine, we can get R is equal to rho L over A, where rho is the constant of proportionality. That is the resistivity of the metal. Okay, now show that the spring constant K naught of the wire is given by K naught is equal to EA over L. Now, E is there. It means Young modulus is there. So now there are 2 marks. Young's modulus. Okay. My dear friends, first of all, K naught they want, huh? Spring constant. So from Hooke's law, first of all, let me write Young modulus. E is equal to, many times I discussed with you, shortcut is FL over A X. Okay, let it be equation 1. So from Hooke's law, F is equal to Kx. But here K naught, so K naught X. This is 2. So what can we do? I can write, put equation 2 in equation 1, something like mathematical terms. So my dear friends, E will be equal to F. In place of F, K naught X L over A X. Now dear friends, X is cancelled with X. So what is left behind? E is equal to K naught L over A. We need to make K naught as the subject of equation. So K naught will be equal to EA over L, and 2 marks you have scored. So just placing the values carefully into the why did I start with Young's modulus? Because this was given E. E is for Young modulus. So Young modulus is stress over strain. And when we little bit simplify it, we are getting FL over AX. So this way we have solved this one easily. Now what is next? Next is the wire is stretched within the limit of proportionality. So it means Hooke's law is obeyed. by a tensile force F. Assume that any changes in the cross-sectional area of the wire are negligible. So cross-sectional area of the wire is not changing. On figure 3.1, sketch the variation of F of the resistance R of the wire. Now here, see force and resistance. Force is causing the wire to be stretched. And according to Hooke's law, extension, which is X, is directly proportional to force because area is not changing, length is changing, so extension is there. And we know that resistance is directly proportional to extension also. Mean extension, not extension. I wrote here actually resistance is directly proportional to length. So when there is an extension, it means length is increased. So extension is increased. So resistance will also be increased. So simply, my dear friends, if you ask me what will happen in between force and extension, sorry, resistance. So as the force is increased, length is increased. And when the length is increased, resistance is increased. So this implies that resistance is directly proportional to the stretching force. So if it is directly proportional, graph should be a straight line and it should pass through region and not a big trick. Only one mark, my dear friends. Again, the wire is being stretched. It means its length is being increased. Area of cross section is not at all changing. Now, the force is causing the extension. He is asking us to draw a graph, to sketch a graph of the force against resistance wire. So when the length is increased, it means resistance will also be increased. So it means resistance of the wire is directly proportional to the stretching force because stretching force will cause or will make the increase in length and that will lead toward the increase in uh, resistance. So force is causing the resistance to increase and directly proportional. Next, my dear. On figure 3.2, this one, sketch the variation with F of the spring constant of the wire. The K. Spring constant of the wire of the K. Graph was a straight line. So now see, we know that F is equal to Kx. So it means K is equal to F over S. Yes, graph was a straight line. Gradient will stay constant. So now see, if the force, like he said, force, stretching force is there, it means force is increasing. So this will make the extension also increasing by the same ratio. So it means the value of if the force is doubled, extension will also be doubled. Force is made half, extension will also be half. So it means the value of K, it will stay same. So straight line like this. Please, dear friends, if there is any question regarding this, feel free, you can ask me. Okay, so the spring constant, we have discussed it K naught. That's why I have R naught is leading towards the K naught. Now, copper has a resistivity of this rho, Young modulus of this copper wire of diameter. Now, this is in millimeters. It means we need to convert it from millimeters to meters times 10 to the minus 3. Resistance is also given. Show that the length of the wire is this. No problem at all. Now see, I used already one formula before. So R is equal to rho L over A. So this implies that length will be equal to RA over rho. And one more step now, only one mark, no need to calculate separately. R, area of the wire, cross-section area. Area is pi r square. But here, diameter is given. So pi r square, so r is equal to d by 2. So it means r pi d square rho over 4. So I am writing the 4 here. Pi d square by 4. So 4 I wrote in the denominator. Now simply I will be placing the values, my dear friends. 0.034 times pi pi times d. That is 1.6 times 10 raised to the power of minus 3. Again, don't forget to take the square because it is d square over resistivity. That is 1.8 times 10 raised to the power of minus 8 times 4. And as we will simplify, of course, it should be 3.8 meters because answer is already given by the examiner. Okay, so that was straightforward, simple. Now, use the equation in B2 to determine the spring constant of the wire. B2. B2 equation is K naught is equal to EA over L. This is the equation in B2. So that's what we derived also. We have to K naught is equal to EA over L. Okay, let's use this equation. K naught is equal to EA over L. Then now let's place the values. Young modulus E is given, yes, 1.3 times 10 raised to power 11. Area of cross section, again the same fashion, my dear friends, pi d square. So that is 1.6 times 10 raised to power minus 3 whole square over 4. So that 4 and length, just we calculated, this is the length, which is 3.8 times 4, which is pi d square over 4. And as we simplify, dear friends, answer comes to be 6.9 times 10 raised to the power of 4 Newton per meter. So that is about the Young's modulus.
Teacher,
Yes, yes, my dear.
why is the area pi
Again, sorry, area what?
d squared?
Basically area,
Why is the area pi d squared?
see, actually we can do it also, but the step will be, one step will be increased. How? See, we are given here the radius of the wire. A copper wire has a diameter, sorry, 1.6 millimeter. Now, my dear son, for a wire, cross-section area is pi r square. Okay. So we know radius is d by 2. Are you with me?
Yes.
We are not given with radius actually. We are given with what? We are given with diameter. So instead of converting diameter into radius and then placing, let's save our time. Simply pi r square, we can write pi d square by 4. Yes, my dear. Is that okay?
Yes, okay. Yeah.
So because if it was radius, we can use radius also. But in this case, we are not given with the radius. Now, what is meant by the diffraction of a wave? This is IGCSE, and 2 marks are there. Very simple definition. So, the when the wave passes a gap through a gap, it spreads out. A wave passing through a gap spreads out. 2 marks. A beam of vertically polarized, vertical polarization. See, light of wavelength this. So lambda is given, that is 540 nanometers, which means 540 times 10 raised to power 9 meters. Is incident normally on a diffraction grating, as shown in figure. So here is the diffraction grating. The diffraction grating has a line spacing of this. Line spacing means D. What does it mean by line spacing, my dear friends? It means D. So this is small d, not capital D. Capital D is the distance between the screen and the slit. Now, the light transmitted by the diffraction grating illuminates a circular screen. So this is, you can see the circular screen here. It is illuminated by the light. The diffraction grating is at the center X of the circle. So diffraction grating is placed at the center of the circle, which is X here, over here. Then the central bright fringe is formed at point O on the screen and has intensity I naught. So here, it means here constructive interference is going on and here intensity is I naught. Bright fringe, so constructive interference. P is a point on the screen where the line XP is at an angle theta to the line XO. XP is an angle theta to line XO. XO is the center line X to O, and XP, this is at an angle theta. And of course, he will be asking us to calculate this angle theta. But for that, we need to know the order of the fringe. Show that the angle theta, first order fringe. So it means small n, that is equal to 1, is 6.2. Even the answer is given. Now, my dear friends, you know, lambda is equal to AX over D. No angle is involved. There is another formula that diffraction grating n lambda is equal to d sine theta. And all the values are with us, by the way. So we need theta. So my dear friends, I can write sine theta is equal to n lambda over d. This implies that theta will be equal to sine inverse and then n, number of the order of the fringe, that is 1. So n is equal to 1. Wavelength, as I told you up there, 540 nanometers. So times 10 raised to power minus 9 over d, that is also given 5 times 10 raised to the power of minus 6. As we simplify it, my dear friends, answer will be equal to 6.2 degrees. Even the answer is given, but anyhow, it is 6.2 degrees, 2 marks. Now, determine the value of theta, which the second order bright fringe. Only, you know, second order, n is equal to 2. Rest everything is same. So, you know, this answer will be doubled. See, everything will stay same. D theta is equal to sine. In place of 1, it will be 2, 540 times 10 to the power 9. So, I will be writing like 12.4, or we can round it off to 12 degrees. Alas. Or even you can write the formula that theta is equal to, dear friends, sine inverse, and n is 2, then 540 times 10 raised to the power of minus 9 over 5 into 10 raised to the power of minus 6. As you will simplify, answer will be equal to 12. You can say 12 point. So you can write simply 12, just double it. Leave. Now, graph is the one. On figure, sketch the variation of the intensity I with theta for the values of theta from minus 15 degree to 15 degrees. Okay. So there will be something, yes. So see here, the central bright fringe is formed at O on the screen I naught, and then theta is 6. Okay, 6 and then 12, got it. So my dear friends, see, this is 0, 5. Okay, first of all, 2 small squares equal to 1 because 5 minus 0 divided by 10. So 0.5. 2 small squares equal to 1. So my dear friends, this is 6. Then 6 2s are 12. So this is 11. This one is 12. Then here also 5. Here this is minus 6, and here then this one is minus 12. So you know 6, 12, minus 6, minus 12. See, 6, 12, that is above this one. Above the central position, this will be first bright fringe is at over here, then at 6 degrees, then at 12 degrees, and so on. Similarly here, minus 6, minus 12, and so on. Below this point O, that will be negative. But these are the bright fringes. Where will be the dark fringes? They will be in the center. So they will be in the center. So 0. So first one is at 6. Okay, wait. I need to write here something. See over here, that will be maxima. In other words, bright fringe. Here also maxima, it means bright fringe. Here also maxima, it means bright fringe. Here also maxima, it means bright fringe. And what is the intensity? They said I naught. So my dear friends, this one point, these are the points of bright fringes. Of course, this O also. Then at 6, this is the point of bright fringe maxima. This is 12, so this is also bright fringe. But what about the dark fringes now? Let's talk about the dark also. So 3. See, this is 1, 2. Here, my dear, that is -3. Then this is 6, so 7, 8. This is -9, 12, and then 15. Okay, now dark fringes. Similarly here. So my dear 5, this is, see, minus, this is 1, 2, this one 3, then 6, this is 7, 8, this one will be 9, and then 15. Now, see, at 12, 6, -6, -12, maxima. My dear friends, at 3, it will be minima, dark fringe. At 9, it will also be minima, dark fringe. At -3, also minima, dark fringe. And at -9, also minima, dark fringe. Even at -15, minima, dark fringe. At 15, also minima, dark fringe. Mean wherever it is maxima, that is constructive interference. Bright fringes are there with intensity of I naught. Why I naught? It is mentioned in the question in the beginning here. See, this is I naught, maximum intensity. And wherever this is minima, it means destructive interference. It means darkness. Destructive interference mean in terms of path difference, my dear sons. Path difference mean integral multiple of, no, n plus 1 by 2 lambda, which means path difference can be lambda by 2, it can be 3 lambda by 2, it can be 5 lambda by 2, 7 lambda by 2, and so on. Wherever it is minima. Wherever it is maxima, it means constructive interference, it means bright fringes, it means the path difference is n lambda, which means 0 lambda, 1 lambda, 2 lambda, 3 lambda. So path difference will be this way. Now we need to plot this graph, and you know very well now till now that I'm not that much good in these drawings, but I will try my best to plot it. So, my dear friend, see, it will start from maximum here. So, which color I can choose? Okay, this one. At 0 maxima, and then here 3 minima, then 6. Please excuse me if it's not that much good. So, you are professors, you people can draw it well yourself this way. This one side is complete. Now for the other side, my dear friends, see, this is minima, and then this is maxima, again minima, then maxima, and then minima, something like this. And see, always this graph they are asking in waves, sometime in terms of intensity with amplitude, and here intensity, but in terms of constructive and destructive interference. This is always there in paper, 2 to 3 marks, 3 marks, 3 marks, 3 marks. So be very careful about this. Now, next is a polarizing filter is placed in the path of the light beam that is incident on the diffraction grating in figure 4.1 in the figure shown. So the transmission axis of the filter is at 45 degree to the vertical. So theta is given. Transmission axis 45 degree to the vertical. Suggest how the variation of the intensity with theta of the light on the screen compares with the answer to B3? That is very simple. You know, whenever there is an angle and something like this, so Molu's law helps us out. So what can we do, my dear friends? We can write that I, first of all, let's see variation of intensity. You know, intensity I is equal to I naught cos square theta. So, my dear friends, I naught cos square 45, that answer is equal to 0.50 I naught. It is reduced to half. Okay. So intensity will become half. Simply, what can we write? That intensity will become half because 0.5 I naught is in front of us. Intensity will become half. Will become half. But peaks mean the at same angles. You know why? Peaks mean the where there are these constructive interferences. So path difference is n lambda, and in terms of angles, that can be 0, that can be 180, that can be 360, like this. So angles will stay the same. Peaks will stay at the same angle, only the intensity will be becoming half. And how do we know intensity is going to become half? That we know because of this calculation with the help of Molu's law. So that waves question, other than this graph, you need to little bit concentrate. Otherwise, it was straightforward. Now state Kirchhoff's current law. The algebraic sum of the current at a junction is zero. Simple is that. So algebraic sum of the current is zero at a junction. I'm writing sum of currents is equal to zero at a junction. Just let's save time. Okay, my dear friends, if there is any question, please feel free. Now, figure shows a circuit containing a thermistor. Here is the thermistor that has a negative temperature coefficient. You know, what does it mean, negative temperature coefficient? It means the resistance of thermistor is inversely proportional to temperature. Mean if the temperature will increase, resistance of the thermistor will decrease. And if the temperature will decrease, resistance of thermistor will increase. That is negative temperature coefficient. There are also positive temperature coefficient, just for an information, that behave same like metals. For positive temperature coefficient thermistor, as the temperature will increase, resistance will also increase. Same behavior like the metal resistors. But this is negative temperature coefficient thermistor. So temperature, mean resistance of the thermistor will be inversely proportional to temperature, and that is a series, a parallel circuit. And also you can see there is an internal resistance of the battery at the same time into the question. Okay. So the thermistor has a resistance or not at temperature of 0 degrees Celsius. On figure, sketch the possible variation of the resistance of the thermistor with temperature between 0 and 100, you know, negative temperature coefficient. So as the temperature will increase, the resistance will decrease. So, but it will never become 0. So my dear, just like half-life stuff, something like this, but stretch it till like this. Very simple, no need to worry. Just as the resistance is, sorry, temperature is increasing, resistance is decreasing. Now, with the reference to the current in the cell, wow, current in the cell, explain why the current in resistor, it, yeah, why the current in resistor R decreases with increasing temperature of the thermistor. with increasing temperature of the thermistor. So we need to do something with the diagram, of course. This is a bit tricky question. This is a bit tricky question. Okay. Now, my dear friends, to explain this, let me go back to the diagram. You know, if the resistance of this thermistor will decrease, so it means total resistance of the circuit will also decrease. Why? Because thermistor is part of the circuit. So when the resistance of total resistance of the circuit will decrease, it means current in the battery or total current will increase. Now, if total current will increase, if you remember very importantly, you know EMF that is equal to I capital R plus I small r. Not, yes. So this is terminal potential difference and this is the volts lost, which are lost here. These are the volts lost. Now he is asking in the question, current in the resistor R decreases. So let's calculate, let's make this C. I can write this E is equal to V R mean terminal potential difference plus voltage lost that is across the terminal. So potential difference across R that will be equal to E minus VR. You know, when the current in the circuit will increase, you know, current in the circuit will increase. So it means this value will increase. So when this value will overall this value potential voltage lost will increase. So this value of course will decrease because if this is more, so like it was total 6 volts. Before total EMF was 6 volts. Before the voltage across R, it was let's suppose zero point 0.5 volts. Now as current is increased, so let's suppose the voltage lost across R that has been increased from zero point 0.5 to 1.5. So 6 minus 1.5, it will be now 4.5. So that's what voltage across R, it will be lost. That's what I'm going to write now, my dear friends. And if there is any question or query even, you can ask me later, okay? So here we can write that increasing temperature of thermistor decreases its resistance. So R total of the circuit is decreased. It means total current in circuit is increased. So we are uh, so lost volts, lost volts that is VR is equal to I small r is increased. So terminal potential difference, better to write. Terminal potential difference decreases, decreasing decreasing current in. This is the uh, actual scenario. If you, okay, let me say it again, my dear friends. I'm just, for explanation, I'm saying E is equal to 6 volts, just for understanding point of view. E is equal to 6 volts. Initially, okay, VR, potential difference across the terminal potential difference, mean potential difference across resistor, it was 5.5 volt, and potential difference across R, it was how much? It was only 0.5 volts. So sum of 0.5 and 5.5 equal to 6 volts. Now, on heating. Now, that was the scenario in the beginning. On heating, resistance of the thermistor decreases. This implies that total resistance of the circuit decreases. This implies that total current, it will increase. Now, see the equation, my dear friends. E minus IR is equal to IR. Now, as current is increased, so this is again, I'm writing 6 minus, before this was 0.5. Now, as current is increased, let it be 1.25. So that will be equal to IR, that is VR. So what will be VR now? It will be 4.75 volts. So it means this VR is decreased. So if VR is decreased, so it means current across this, resistance of this resistor is constant. Resistance of this resistor did not change. VR basically is equal to IR. Current is decreased. Why? Because the resistance is staying same. Resistance is not changing. Resistance of what? Resistance of the resistor is staying same. So something like this, these numerical data will also help you out to understand this concept. If there is still any question, please feel free. You can ask me. Now, the electromotive force, E of the cell in figure 5.1 is 1.5. They gave this EMF now for that cell. The internal resistance of cell R is small r, that is also given. Resistor R has a resistance of this, capital R is given. At a particular temperature of the thermistor, the current in R is this. Current in R is this. So now, for this temperature of the thermistor, determine the current in the cell. So total current we need to calculate. Current in the cell. I is equal to V over R. But in this scenario, my dear friends, current in the cell will be equal to VR over R. Why so? Now come here to the diagram. See, the current coming from here will split here into R and this. But whatever is the current in the battery, same will be the current in this internal resistance, because this internal resistance is in series with the battery. So whatever is the current in the internal resistance, same will be the current in the battery. And why did I'm using this? Why I'm using this view? Because I have the voltage, I have the EMF of the battery, I have this resistance of the cell. So when these values are with me, so simply I'm placing this to get the answer. Okay. So now, my dear friends, VR. This is equation one. 2 marks are there. Now, first of all, let's calculate what is VR. As I wrote up there, my dear sons. Now, we can use the formula E is equal to VR, voltage, or terminal potential difference across resistor, and VR. Okay. Now, we can calculate this VR. VR will be equal to E minus V capital R. Now, E, that is 1.5. E 1.5 minus I. See, current through R is this, and R is also given. So it means, my dear friends, 0.2 times 6. And as we will simplify, so VR, that will be equal to 0.30. So my dear friend, this is equation 2. So what I did, VR means IR. Okay, so that's what I have used here. Now, this value is with us. Now place this value of VR here. So my dear friends, VR is 0.30 over R. Internal resistance of the cell is given. How much is that? 0.12 over 0.12. On simplification, it will be equal to 2.5 amperes. So my dear friends, 2.5 amperes. So it's just basic equation for the circuit containing a battery with internal resistance, which is EMF of the battery is equal to the voltage or terminal potential difference across the external resistance plus the voltage lost across the internal resistance R. Internal, and this is external resistance. Okay. Now the resistance of the thermistor we have to calculate. Resistance of the thermistor, that is very simple. R will be equal to V over I. So, my dear friends, voltage across R, we can calculate, IR over current minus current through the battery. Okay. So, what can we do? See here, current through R is 0.3. So, I minus IR. So, my dear friends, what can we do here? See. So, that is 6. No. See here, this current, this is 0.200 times, my dear friends, 6 over total current we just calculated, it is 2.5 minus current in the battery. Current in the battery, my dear friends, we can calculate. No, sorry, total current minus current across R, that is given. Current across R, my dear friends, that is 0.200. I think I'm tired now. Bit lagging in concentration. I will re-explain it. But on simplification, my dear friends, we will get 0.52. So here, resistance is 0.52. Wait a minute. We need to calculate the current, the resistance of the thermistor. So R will be equal to V over I. But we have to check about the thermistor. Now, first of all, the voltage across the thermistor, the resistance of the thermistor. So that will be, first of all, I into R. At a particular temperature of the thermistor, the current in R is this. So 0.200 here times, my dear friends, 6. That will give us the voltage. And why I'm using this, which is across R, because this thermistor and R, they are in parallel. So whatever the potential difference here, same will be the potential difference here. So that's why I just put the value of potential difference across R. So 0.200 times 6 I calculate. Over total current is 2.5. And we know the current through this resistor is 0.200. So see here, total current we calculated in the battery, that is 2.5. This is how much? 2.5 ampere. And current through this, that is how much? 0.200. It is mentioned. So what will be the current here? That will be simply 2.5 minus 0.200, because this is a parallel circuit. So sum of the currents in the branches is equal to total current in the battery. Kirchhoff's even second law from volt. This mean parallel combination properties we can use. That potential difference is same. That's why whatever the potential difference across R, same I have used across T. But the current in the battery is 2.5 amperes, whereas the current in R that is mentioned, that is given 0.200 ampere. So what will be the current in the thermistor? Total minus current through the resistor, that will give us the current through thermistor. That's what, my dear friends, I have used. R is equal to V over I. So here simplified and got the answer. Now, next question, the nickelide 1H3, an isotope of hydrogen that is called tritium. Tritium 1H3. Determine the number of protons, neutrons, and electrons. This is protons, 1 electrons, 1 neutrons, 3 minus 1. So that is equal to 2. Straightforward. Then draw a labeled diagram to represent what? Labeled diagram to represent a simple model of the arrangement of the protons, neutrons, and electrons in tritium. So let's suppose there is a nucleus which is having proton, 1 proton, 2 neutrons. That is nucleus. See, neutrons are 2. So 1 proton, 2 neutrons in this way. Or arrangements of proton, neutrons, and electrons. Okay. Then there can be 1 electron orbiting around the nucleus. So here, my dear friends, electrons. So we can write E for electron. Key you can give because there are 2 marks. P for proton and N is for what? Neutron. Even you can do it another way. Electron, you can write negative this one here. For proton, you can write positive and this one here. And for neutron, you can write like simple this. So here you can write positive sign, then 0, 0. And outside you can see circle with a negative sign. That can also be done, but it's okay, whatever we have discussed. That's not a problem. Now, tritium is a radioactive and undergoes beta minus decay to form an isotope of helium, He. Gamma radiation is not emitted during this decay. Complete the equation to represent the radioactive decay of the tritium. So this is again, I would like to say that is from IGCSE. So helium is, 2 He4, beta, this is -1, and here 0, so 0, 0, no, I'm wrong here. It cannot be 4. My dear friends, it should be 3. The reason, see, 3 plus 0 plus 0 equal to 3. Nuclear number conserved. Proton number plus 1. So 2 minus 1. That is also equal to what? Plus 1. So be very careful. Don't write helium directly here 4. I did mistake, but then state the name of the particle X. So particle X, 0 mass, 0 charge. So it is neutrino, but electron antineutrino. Anti You can write electron. I forgot to write in the beginning. So electron antineutrino. Simple is that. Now, my dear. Next is, if it was positron, so it was neutrino only, electron neutrino, if it was positron. But here they said it is beta particle. Beta plus, then electron neutrino, beta minus, antineutrino or electron antineutrino. Now, determine the quark composition of a tritium nucleus. Tritium nucleus. Tritium nucleus, my dear sons, it was given in the previous page. That is 1h3. So quark composition. Electrons are out. Electrons are still fundamental particle. Quark composition, we need to write about the proton and neutron. No, proton, that is UUD. Up, up and down quark. Whereas neutron, that is UDD. Okay. Now, how many protons are there? Uh, so there is one proton. My dear friends, what can we do? 1h3, that is converted to one proton, and one proton has two up and one down quark. Okay, and then it has two neutrons. Two neutron mean it has each neutron has one u, so it means 2 times u, and then 2 times 2 down, because down or 2 they are already. So you can write here 1 u even. Okay, now this is basically the quark composition. Now how many are down quarks, my dear? 2 plus 2 4 and 1 5. So down quarks, see, 2 into 2, it means 4 down here, and this means 1 down here. So 1 plus 4 down, it means 5 down quarks. Okay, and what about the up quarks, my dear sons? See, up quarks are there. Here there are 2 up, and here there are also 2 up. So uh, up quarks are 2 plus 2. 5 up, sorry, 2 plus 2, 4 up quarks. That is very simple. Okay. So close to the exam, you will memorize this also in this way. This paper is done. I think comparatively it was average paper, not that much difficult. Any question, any query, feel free. You people can ask me now, even later on during the next lesson on WhatsApp. I'm always available for you people, my dear friends. Stay blessed and safe. And Assalamu alaikum.
Alaikum